In this lesson, you're going to start connecting external components to your Arduino board. In the last lesson, you used an LED that was already present on the Arduino board. However, in most practical projects, you'll need to connect external components to the board. And to make these connections, the Arduino has several pins of different types. Although these connections are commonly called pins, you can see that they're not actually physical pins. Rather, the pins are holes in a socket to which you can connect jumper wires. And in this figure, you can see several different groups of pins. This first set is 14 digital pins. There's also 6 analog pins, and then 5 what are considered power pins. Let me go over them one by one. In the orange rectangle, there are 14 digital pins that you can use as inputs or as outputs. The fact that they're digital, there's only 2 levels that are recognized. First is level 0, which is represented by a voltage of 0 volts. And then level 1, or on, you could think of it as, is represented by 5 volts. Going down to this green rectangle, you can see 6 analog pins. Now these are used as analog inputs only, and they work between 0 volts and 5 volts. And last, you have this blue rectangle, which is 5 different power pins that allow you to power external components. So for this lesson, to get you started, you're going to connect an external LED, and it's going to run that same blink example sketch. The built-in LED is connected to digital pin number 13. So you're going to connect an external LED to that pin. As a good practice, you should disconnect the Arduino board from the computer first. So once you've done that, now you're ready to hook it up. Let me show you what it kind of looks like. So I'm going to flip the Arduino board over, and you can see here coming out of pin 13 as an output in this case, going into the resistor, in this case it's that 470 ohm resistor. Mine's blue, though this picture has as a tan. It goes into an LED and then out of the LED back to ground. If you haven't worked with LEDs, as all diodes, they are polarized. LEDs, light-emitting diodes, are sided. The positive terminal is called an anode. It's generally the longer of the two. In this case, in this picture, you can see they're all on the right side. The negative terminal is called the cathode, and it's typically shorter. There is one other way that if the LED has already been installed in something and you're reclaiming it, and maybe the legs aren't obviously different lengths, LEDs like this style, the cathode side of the colored case also has sort of a subtle flat edge. And you can see me pushing my LED around on the table here, and you can see it sort of flatten out on one side and stick. You can also see it here in this photograph, though it's really subtle, that this is the flat edge, indicated here again with that shorter leg. Something I didn't know before, but it's kind of a handy trick. In my case, I'm going to use a breadboard, so I don't have to solder all those things together. And it's going to look something like this. Coming out of pin 13 on the Arduino, because this will match up kind of close to this, I'm going to come into row 14 here, next to 15, 14, into this pin I. Then I'm going to connect the resistor here from H14 across to, I guess this would be H18. And then jump here across here. Again, you can kind of follow the positive voltage traveling across here. And this is going to connect a bridge here, coming into the anode of the LED, which is coming across on H20. And then its cathode is here on 21, H21. Then there's a minor difference between this diagram from the article and how I've connected it, which I'll show you in a moment. And pin 21J over here to the blue bar. So that, again, this runs all along here. So coming back in, going into the ground. So let me show you what that looks like. I tried to duplicate that image as best I could, but I think I got one row off as far as row 17 and 18. Okay, here you are with the Arduino. Coming out of pin 13 with a jumper into J14. Then that's connected automatically to H14 where the resistor comes in. Then that's coming out, the resistor on H17. There's the jumper at G from 17 to 19. The anode is in H19 and coming out 20. And then 20 J is running over here to the blue negative terminal, which then runs back into ground. And load that sketch again. If it's not already loaded, you should see not only the L LED flashing, but this red LED or whatever color LED you have will flash along with it too. So now I'm ready to re-plug in the USB cable, and that program was already in its memory. It just needed power again. And you can see the L light and the LED flashing at the same time. Once a second. Now that you've connected some external components, let's start using Python. And that's up in the next lesson. In this lesson, you'll recreate that Hello World Arduino program using Python. Up to now, you've primarily been using the Arduino language, even though you haven't dove too deep into it. You've seen that sketches are written in a language that's similar to C++. They're compiled within that IDE. They then get uploaded to the flash memory of the microcontroller. Well, how's it going to be different using Python with the Arduino? Well, you're going to need a direct connection to the Arduino. Instead of uploading the sketch into its memory, you're going to remotely control the Arduino via that USB connection. This means that the main program will be running on a PC using Python. Then it's going to use a serial connection, the USB cable, to communicate with the Arduino. So on the Arduino, there has to be a sketch that can read the inputs and the outputs. This sketch is going to send input information to the PC, say from buttons or switches or different types of input controls and sensors. But also it needs to receive updates that are coming from the PC and translate those to the outputs on the Arduino. How are you going to accomplish this? To do all that, you're going to use Fermata. It's a standard protocol for communication with the Arduino. It establishes a serial communication format that allows you to read those digital and analog inputs, and then allows you to send the information to the digital outputs. And just like we were discussing in the previous slide, you upload that to the Arduino as a sketch. So let's talk about that process of uploading it. You'd open up the Arduino IDE and then select File, Examples, Fermata, and you'll see Standard Fermata. Let me show you what that looks like here inside the Arduino IDE. You might still have the Blink sketch open, so go ahead and close that. And then again, you're going to go to File, Examples, Fermata, and there you'll see Standard Fermata. So here's the sketch. Now go ahead and plug in the USB cable to the PC and reconnect the Arduino. You should see a little bit of flashing and the power light come on again. And then make sure the appropriate board and port are still selected in the IDE, or reselect them, just like you did in the earlier lesson. From Tools, make sure the appropriate board is selected. And also from Tools, make sure that you still have your port selected. Again, don't forget the name of the port. You're going to use that shortly. That all looks great. Then, with the Fermata sketch ready to go, and the USB connection established, you'll press Upload to send that sketch over to the Arduino. You can verify that it compiles, and then use this to upload it. And once you press that Upload button, you'll see a lot more activity over on the Arduino, because it's a much larger sketch than you've used before. So the transmit and receive light flash for a little bit. Once all that activity is done, it should switch. Only the power LED is on. Okay, now that all that is working, there's just one more step before you can start using Python. To work with the Fermata protocol in Python, you need to install the pyfermata package. And that's done using pip install pyfermata. So let me switch over here. I'm going to be using Visual Studio Code. Okay, in my terminal, I've created a virtual environment. You don't need to do that. I'm just going to do that because I do lots of tutorials and have lots of different setups I have to create for those tutorials. So in my case, I'm already in my environment, and I'm going to run my command to install the pyfermata. So python-m pip install pyfermata. Okay, looks good. And then you're going to create a new file. I've created a folder, a directory called Arduino, so I can kind of keep it all together. And you're just going to create a brand new file. It'll be a Python script. It's going to be called blink.py. So I'm going to open it up there. Okay. What goes into blink.py? First off, you need to import PyFormata. And you need to import something from the standard library of time. Import time. Here, you're going to create an object called board. And this is literally a connection using PyFormata to the Arduino. And I told you this was coming up. Here's where you choose that USB connection. And mine is /dev/USB. Wait, I missed something. cu.usb modem. And then 14601, which is the number of the port. All right, again, this is going to look totally different on your machine. Just remember, it's that thing that's under port. Again, that text string, if you will. Great. Now, make a while loop, and this is where you're going to control the board. So while this is true, it's going to keep looping this code around. Board, the one you created a moment ago, right? Now you can talk to a variety of things. So one of them is digital. So that means talk to those digital pins. Let's talk to digital pin number 13. That's where that LED is connected, right? And you can write to it. Okay. What does write take? Write takes a parameter of a value, and it's a 0 or 1. So 1, you might remember, is on, or 5 volts. So that will send a value of 5 volts to write. Time, we'll have it sleep. Sleep takes a parameter of seconds. We'll say 1 second, just like that other sketch did. Board, digital. So stay on 1 second, and then write again, put a value of 0. So that's going to change the pin to 0, turning the voltage off, or 0 volts, and make it sleep one more time for a second. So again, on, sleep for a second, off, sleep for a second, on. So blinking, right? Go ahead and save. So down here, I just need to run this script, and then we can change and look at what happens as you send that information over to the Arduino. So running Python blink.py. There's a little bit of flashing of the LED light and the transmit light, but then you can see it receiving the message to turn on pin 13 and light up the LED once a second and receive a message to turn it off. So there's your blink Python script. If you halt the script using Control-C, like I just did there, you'll see the LED stay on, because that was the last command it received, was for it to be on. In the next lesson, now you've done a little bit of output from PyFormata, I'm going to show you how to read digital inputs.